How many of you have looked through a telescope before at something in the sky? Good, nearly everybody. Yeah. We hope we have some nice telescopes out there to give some good viewing. So what I'm going to talk about tonight is some of the objects that are going to be out there, so that we know if I mention globular clusters and things like that, you'll know what we're talking about. So the objects that are out tonight: the moon. 3 of the 5 naked eye planets are out: Mars, Jupiter, and Saturn. Saturn and Mars might be a little hard to see because they're kind of blocked by the trees over in the east. They're in the east, and Jupiter is in the western part of the sky. Double stars, I'll explain what those are. Star clusters. Nebulae, which are gas clouds in the sky. And galaxies. So we'll start with the moon. The moon, as you know, is not always completely lit. Sometimes it's only lit in a very small crescent. Other times it's fully lit, and other times it's more than half lit. And the reason for that is because the moon orbits the Earth, and so this little diagram, not to scale of course, shows that when the moon is directly between the Earth and the sun, the side of the moon that's lit up is always the side facing the sun. And so what we see is the side that isn't lit up. Or actually, we don't see it because the only reason you can see the moon at all is because of reflected sunlight. So there's no reflected sunlight over here, and that's called new moon. Now then, as you go along, as the moon orbits, a bigger and bigger piece of it gets lit. First it's only a tiny little slit, and then it's more and more, and that's called a waxing crescent, waxing meaning increasing. Then when the moon is at right angles to the Earth, half of the moon is lit up, half of the lit up side is visible from the Earth, and that's called a first quarter moon. Then as you move along this side, more and more of it is lit up, and there's actually more lit up than is dark, and that's called a waxing gibbous phase. We're about exactly where this picture is right now. That's what we've got out there in the sky. And when you're in the waxing gibbous phase, in the afternoon, the moon will already have risen, and it's visible in broad daylight. Then, when the sun and the moon are on the opposite sides of the Earth, the side that is illuminated by the sun is the whole side is facing the Earth. That's called a full moon. And then it goes in the reverse direction. You get less and less lit up until over here, the other side, the other quarter is half of it is lit, and that's called last quarter. And then you get a crescent, and then goes back to new moon, and the whole cycle starts over again. Now, one of the other things about the moon is you'll notice that the moon always has the same side facing us. It always looks the same, no matter what part of its orbit it's in. Anyone know why that is?
Is it because of the slant of the Earth?
No, it's because the moon's period of rotation, the moon spins around on its axis just like the Earth does. The Earth goes around once every 24 hours. The moon spins on its axis once every 28 days. And it happens that it also orbits at exactly the same rate. This is due to tidal effects of the Earth's gravity. And so, if you do an orbit around something, I'm going to orbit your audience here, and I'm going to also turn around once on my axis at the same rate as I'm orbiting, and you notice that as I keep turning, I'm always facing you. And I won't do the other half, but that's why we always see the same side of the moon. And it wasn't until we sent spacecraft to photograph the far side of the moon that we finally got to see it. And it turns out that it's not as interesting as the side that faces us. The side that faces us has a lot fewer craters than the other side, and I think that's probably because the Earth and the Earth's gravity pulls in a lot of the junk that would otherwise have whacked that side of the moon.
Sometimes in the news they say that tonight the moon will be a little bigger. So why do they say that? Or is there any reason for that?
Yes, it's because the moon actually is bigger, and it's because all of these orbits of planets around the sun and the moon around the Earth and the various moons of the other planets around them are ellipses. They're not circles. They're very close to circles, but they're not actually circular. So it's a little bit offset. It's actually kind of like this, an oblong orbit. And there are times when the moon is closer to us. That's called perigee. And there are times when it's further away, which is called apogee. And you may recall just this last fall we had a total lunar eclipse where the Earth's shadow cast in front of the moon. And that was a particularly noteworthy eclipse because it happened at perigee, which means the moon was very large at that time. So going on to the planets, the first planet out from us is Mars, and it's a reddish-orange color. This over here is very much like what it looks like in an amateur telescope. This, in fact, is an image taken through an amateur telescope by one of our club members, Rich Schuller. And you can see some details on Mars. You can see there's some dark markings, and also there's this white spot down here, which is the south polar cap. Just like the Earth has ice caps on the north and the south poles, so does Mars. Their ice caps, though, are frozen carbon dioxide, not frozen water, because it's a lot colder out there. Mars, because it gets very close to us proportionally versus when it's on the other side of the sun from us, it varies an awful lot in brightness by a factor of about 10 or 12. It's currently quite close to, at its, one of its closest approaches to us, and so visually it's very bright. It's almost as bright as the planet Jupiter. And so this is actually a very good time to be seeing it. And Mars is about half the Earth's diameter. It's a smaller planet than the Earth. And it does show some features on it. We'll have to see if we can actually see Mars tonight. It might be in the trees. If not, then we'll try to show some of the features. Going on to Jupiter, this is an image of Jupiter taken by the Cassini spacecraft when it went by Jupiter. It swung by Jupiter on the way to its final destination, which is the planet Saturn. And while it was passing Jupiter, they took some pictures of Jupiter with the Cassini spacecraft, and this is one of them. The distinguishing feature, Jupiter is a gigantic planet. It's many times bigger than the Earth. And it is a big ball of gas with these opaque clouds at the outside, and so we can't really see inside, and we don't know if Jupiter has a surface. We suspect not, although we think it might have a metallic core of hydrogen. These are very noxious gases. They include sulfur dioxide and methane and other things that you wouldn't want to breathe. And these dark bands, alternating dark and light cloud bands over here, are actually visible even in small telescopes like the Library Telescope. You can see this band and that band pretty clearly. In this southern dark band, there is something called the Great Red Spot. It's actually more of a big pale pink spot. And as you can see in here, it looks like the swirly effect, just like when you've got some of those aerial photos looking down on a hurricane. And that's exactly what this is. This is a gigantic cyclone storm that has been in the atmosphere of Jupiter as long as there have been telescopes around to see it, so a couple of hundred years or more. That storm has been there. You can see that it leaves a bunch of turbulence behind it, and also that there are some smaller storms of a similar sort here and there in Jupiter's clouds. Now then there's this dark black spot over here. What that is it's the shadow cast by one of Jupiter's moons. Jupiter has about 40 or 50 moons all told. And of those, there are 4 of them that are big enough to be seen through telescopes on the Earth. And again, you can even see them in binoculars, the 4 largest. They're called Ganymede, Io, Callisto, and Europa. This is this is an image of Jupiter that was taken by Gardner Gary. This shows more what it looks like in small telescopes. You can see those 2 very prominent dark bands. Again, you can see the Great Red Spot here. Now, the interesting thing about this image is that Gardner managed to catch the moon Io as it was passing in front of the planet Jupiter in its orbit, from our point of view, and casting its shadow right into the center of the Great Red Spot. So that's a pretty neat photo. This is a series of photographs of Jupiter taken by Herb Hubert through his telescope. And the 6 go in order over here over a period of about 3 or 4 hours. And again, you can see a lot of cloud bands. These are very sharp images, and the great red spot. And the notable thing about this series of images is that 2 of the moons were casting their shadow on Jupiter's clouds at the same time. And so, if you compare this image to that image, you'll notice that both the 2 moons and the red spot are a lot closer to the edge of the planet over here in this image than they are in that image. And that's because, of course, the moons are orbiting, and as they orbit, the shadow moves. And also, Jupiter itself is spinning on its axis. The day in Jupiter is 12 hours long. It spins about twice as fast as, in terms of rotation, as the Earth does. And so, the red spot has also moved in a little bit from the edge. And I kind of call this the face on Jupiter. It looks to me like 2 eyes and a mouth on the planet. Next, there's Saturn. This over here is an image of Saturn that was taken by the Cassini spacecraft when it finally arrived there and was approaching the planet. Saturn's most prominent feature, of course, is this very bright series of rings. And what those rings are dust and crystals of water ice. And they are very, very highly reflective. There are also some gaps in the ring system here and there. This big one is called the Cassini gap, in honor of the astronomer who first discovered it. And the other notable thing about the rings is the rings are very, 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 very thin. They're not very wide. They're very wide at all, but they're not very thick. They're only about as thick as this room. And so it's pretty amazing that they shine so brightly, even from a distance of almost 1 billion miles. This image also managed to catch 2 of Saturn's moons. Saturn has about 60 or so moons. They keep discovering more of them. Of them, there are 7 of them that are visible in small telescopes. Yes?
So how many did you say, 6?
60, 60.
I thought 60, yeah.
Yes.
Wow.
Now, they vary in size from a very large moon called Titan, which is actually large enough to have its own atmosphere. It's much larger than our moon. And it's about 1/3 the diameter of the Earth. And Titan has oceans on it. They sent a probe down from the Cassini spacecraft, and it was taking pictures as it crash landed on the moon Titan. And you can see actual rivers and oceans on there, and hills and mountains. The hills and mountains are made out of frozen water, and the rivers and ocean are liquid methane, because it's very cold out there. But it is actually large enough to have surface features. You look at that and you say, that's a coastline, that's a river going down there with a river delta. Very much, first time that stuff had ever been seen anywhere but on the Earth. So there are 7 moons, Titan, Tethys, Rhea, Dione, Mimas, Enceladus, and Japetus. I actually got all 7 of them. There are 7 of them that are visible in small telescopes, and about 60 or so in all. This is another set of images that Herb Hubert took through his telescope of the planet Saturn over the years. This is starting in February 2004, and 1 image each year up till last year. He hasn't posted the next one in this series. I assume he's imaged Saturn by now, but he hasn't posted the new image yet. And the notable thing on here is that the tilt of the rings changes year by year. Over here, we are looking down at the rings from the top, and then by the time you get down to 2009, we're looking at them almost edge-on, and then in the next year, in 2010, we were looking at it from the bottom, and now we're looking at it more and more from the bottom as time goes by. The reason for this is that the orbits of the planets are very much in the same plane going around the sun, but they are slightly tilted to each other, so kind of like this. And if this is the Earth's orbit, then when we're on this side, and Saturn is down here. We end up looking down at it from the top. Where the orbits cross, where the planes of the orbits cross, you end up looking at it directly edge on, and then you're looking at it from the bottom. In 2009, it was around this time. I saw it a little bit later than this picture was taken, and Saturn looked very strange. The rings were completely edge on. You couldn't see them as rings at all. It looked like two bowler hats that had been glued together. Now the other thing on Saturn, as you can see here, is that you can see some little bits of detail. Saturn also has bands in its clouds. They're not as prominent as Jupiter's, but they are there. We'll now go on to double stars. A double star is a star that appears to be only one star when you look at it visually, but then when you turn a telescope on it, you find out it's two or more stars that are just happening to be very close together, and you need the extra magnification of the telescope to split them. And so this is an example of a double star. It's called Mizar. It's the middle star in the handle of the Big Dipper. And if you look at it, it appears to be only one star when you look at it with the naked eye. There is a dimmer star that's nearby. That star is called Alcor. And in this view, that's Alcor down here. They appear to be almost on top of each other without the magnification. This is about a 50x magnification, I would say. And you can see that Mizar is actually two stars, one of which is about half as bright as the other one. And there are a bunch of double stars that we can show you tonight. This is just one example. The next kind of object I'm going to show you is something which is called a globular star cluster. This is very much what it looks like in a 14-inch telescope. It looks like someone dropped a little round pile of sugar in the sky. Each of those little spots in there is a star, and you can see that there seem to be countless thousands of them. And these are all in the same part of space. They're all gravitationally attracted and mutually orbiting around the center of the cluster. And they get more and more crowded as you get to the center until you can't distinguish individual stars anymore. This object is very, very far away. It's about 13,000 light years. In contrast, the nearest star to us other than our sun is 4.5 light years away. So it's very, very far away indeed, and that's why these stars appear to be crowded together like that. But they are traveling through space together. This is an image of M13 at greater magnification, and you can see that there are just uncountable numbers of stars. The estimate is there's about a million of them in the whole cluster, each of which is probably larger and brighter than our sun. Astronomers have cataloged and individually studied 70,000 of them. The next kind of object is what's called a nebula. Nebula is Latin for small cloud, and that's what they are. They're small clouds of glowing gas in the sky. They glow for various reasons. Some glow from reflected sunlight, from reflected starlight. Some of them glow because they are lit up by a star. They're phosphorescing, and by the same principle that these fluorescent lights work. They're fluorescing. And there are others of them that are glowing because they've been heated up. This is a nebula called the Ring Nebula in the constellation Lyra. It's called the Ring Nebula, as you can see, because of its donut shape. And what it is a dying star. When stars stars glow like our sun. Our sun shines because there's nuclear fusion going on in its core. And hydrogen is being fused to form helium, the same principle that makes a hydrogen bomb work. Now, after billions of years, a star eventually exhausts all of its hydrogen, and all the hydrogen has been fused into helium, and there's not enough left over to keep the shining going. And when that happens, there's no longer enough pressure from the energy from the fusion to counteract gravity pulling all of the gas into the center of the star. The star's core shrinks down, and one of the consequences of that is the outer layers of the star get blown off. And when they do that, they tend to form this kind of smoke ring. It's a torus around the center, and that spot right in the center over there is the exposed core of the dying star. This glows over here. That center part is exceedingly hot. It's blue-white, and it in fact radiates mostly in X-rays and ultraviolet light, unlike our sun, which radiates mostly in yellow and green, which is why it appears yellow to us when you look at it. This appears blue-white, as you can see, and the intense ultraviolet light causes that blown-off outer layers of the star to also glow with fluorescence. And in this case, that ghostly bluish-green color that you see here is from glowing oxygen gas in the outer atmosphere of the star that's been blown away. This smoke ring will eventually dissipate, and what will be left is just the collapsed core of the center of the star, which is what is called a white dwarf star. So this is a white dwarf in the process of forming. We believe that when our sun exhausts its nuclear fuel, it will also do this. We don't have to worry about that happening for a while yet. We guesstimate it'll take another 10 billion years before we have to worry about the sun doing this.
What's the core made out of, comprised of?
It's comprised mainly of helium and also some heavier elements like carbon, oxygen, nitrogen, and even some even heavier elements, all the way up to iron and mishmash of everything, but mostly it'll be helium at this stage. Because what happens is the helium itself, the stars like this are not, and like our sun, are not massive enough to start fusing helium into carbon and oxygen. And so what happens is the helium, being denser than the hydrogen, gravity tends to drag it towards the center of the star, and it eventually builds up. And then once you no longer have enough hydrogen around to carry the nuclear fusion, then there's nothing to prevent gravity from collapsing the whole thing down, and that's when you get that kind of thing. I'm not going to galaxies. Galaxies are what I like to call them space cities, star cities in the sky, and they are collections of stars, usually orbiting a center point, and in these cases we're talking about hundreds of billions of stars. This is one called M51. It's in the constellation Ursa Major, just under the handle of the Big Dipper, the end of the handle of the Big Dipper. There's actually two galaxies here, this round one over here, and a lot of them have this spiral shape where you have a central core, and then you tend to have two arms spiraling outwards from it. And the whole thing is kind of flattish and rotating like a pinwheel or like a frisbee. And also you tend to get, in most galaxies, a dark dust clouds along the spiral arms. So this is a Hubble Space Telescope image of M51. In smaller telescopes, you can't really see much other than the core and some glow around it. In my 14-inch telescope, I can, under best conditions, just barely make out some of the spiral arms. If the larger the telescope you have, the more you can see that way. This is a pair of galaxies called M81 and M82. They're also in Ursa Major. They're off the bowl of the Big Dipper. And one of them is round like this, and the other one just appears to be like a pencil streak of light. This is very much more like what they look like in small telescopes. This over here is a Hubble Space Telescope image of M81, which is the one on the left here. This is what it looks like in the Hubble. And again, you can see there's a central core with about 100 billion stars in it, and the rest of the stars, there are two spiral arms. And this one is not face-on to us the way M51 was. This one's tilted somewhat. M82 from the Hubble Space Telescope looks like this. You have, again, the central part of the galaxy with maybe some spiral arms, but you also have two jets coming out from the center, and they appear red in this image because they're glowing hydrogen, and hydrogen glows in visible light in the red and purple parts of the spectrum. And so that's why there's this reddish-purple color, these jets coming out from the center. So we think there's some massive explosion going on in the center of M82, possibly a black hole that is feeding on other stars. And as they get torn apart, some of the material gets slingshot out from the poles of the rotation of the black hole, And that's what forms these big jets of hydrogen coming out. Here's two more galaxies over here. This galaxy happens to be, or these two happen to be oriented exactly edge on to us from our point of view. And so again, you see the core over here, but the spiral arms, you can't really see the spiral structure at all because we're looking at it on the edge. You can just see the dark cloud of non-glowing dust that I mentioned before. And here you see the same thing, the central core and the dust over here. This top one is a galaxy in the constellation Andromeda called NGC 891. This one down here is the galaxy we live in. This is our Milky Way, and this is a panoramic image that someone took by pasting together a bunch of images they took of the Milky Way. And so the center part over here is in the constellation Sagittarius, and as you go outwards in this direction, that part is in the constellation Scutum. The constellation Cygnus is about over here, and as you go down here, you get to the constellation Perseus out on this edge. And so you can, so what we're seeing here, this is what a spiral galaxy looks like if you're on the inside of it, looking outwards or inwards. As you look inwards towards the center, you're looking towards this part over here, which from our standpoint, our point of view happens to be in the constellation Sagittarius. And as you look out in the other direction, outwards, instead of towards the core of the galaxy, you're looking towards the constellation Perseus. And so this is an artist's conception of what our galaxy might look like if we had the same view of it that we have of M51. Again, you have the central core over here and two main spiral arms plus some stragglers. This over here is where our sun is relative to the center. The whole thing is about 50,000 light years in diameter. Their radius, 100,000 light years in diameter. We're about 2/3 of the way outwards over here. And again, as we look outwards towards Perseus, we're looking this way. And as we look towards Sagittarius, we're looking that way. Now this is another artist's conception, and it shows just how small the amount of space you can see with your naked eye really is. Just about everything you can see, with one exception, well, with three exceptions, everything that you can see with the naked eye in the sky is part of our own Milky Way galaxy. The three exceptions are, our Milky Way has two satellite galaxies, two independent galaxies that are rotating around it. They're called the Magellanic Clouds, the small and large Magellanic Clouds, and those are not part of the Milky Way proper. They're not visible, unfortunately, up here in the north. You have to go south. I've seen them because I visited Australia to do observing. And the third thing that you can see is there's one galaxy that under best conditions you can see the very core of it naked eye. And that's the galaxy called M31. It's the closest large galaxy to us. And you can just barely see it as a tiny fuzzy spot. So this is an artist's conception of, that's where our sun is over here. And this circle of dots around there is how much of our galaxy contains all of the many, many thousands of stars that you can see at night with the naked eye. To see anything else in the rest of our galaxy, you need a telescope. Okay, so that's it for the indoor presentation. We're a little bit past sunset, so we've still got some time to kill. If you've got any questions on astronomy, on any subject at all related to astronomy, I'll try to answer them, or I'll say I don't know. Any questions? Yes?
Explain when they talk about a double moon. Have you heard that?
No, I haven't heard that.
Okay.
In what context are they saying double moon? Our moon? Or?
Yeah, I mean, I remember quite a few years ago, they said that there was going to be a double moon, and I never...
I think I know what's meant by that. That's also called a blue moon.
A blue moon?
Yeah,
Okay.
and what it means is, normally we have, the Earth's rotation here, the moon's rotation, revolution around the sun takes 28 days, as I mentioned before. And the Earth travels around the sun in 365 days. So there are 12 and a bit rotations of the moon every year. And that, in fact, is why we divide the year into 12 months. The mon in month is from moon. Now, it's not quite, if you divide 365 by 12, you end up with roughly 30 days in each month, which is a little bit longer than the 28 days. So it's possible occasionally to have one full moon at the very beginning of a calendar month, and one near the very end of the calendar month. Now, this is assuming you're using the Christian calendar, which is based on the Roman and Greek calendar. There are also a bunch of calendars that the Babylonians had and that are still in use in Judaism and Islam, which are lunar calendars. And they have months that are 28 days long, and they do some fudge factor with leap days in order to make that more or less synchronized with the year. But their months wander around the year. Anyway, so it's possible to have a full moon at the beginning of the month and a full moon at the end of the same month. And that's what would be that double moon you're talking about.
Okay.
And that's also the second full moon in a given month. It's called a blue moon. Hence the phrase once in a blue moon, which doesn't mean never happens. It means it happens very rarely, only occasionally. I don't know what the frequency of blue moons is, but they don't happen every month or even every year, I don't think. Yes?
What happens on new moon? Does the moon give you light on the moon?
Yes, but the side that is facing the sun, we're behind the moon. You know, if you were let's say the sun is over here, and I'm the moon, my backside is lit up,
Right.
not the side facing you. And so that's why you can't see the moon.
And that happens once a month?
That happens once a month, yeah. That happened about 2 weeks ago.
Also, it's like sometimes you see stars falling towards the earth, and sometimes you see, like, I mean, very
Well, those aren't
frequently.
stars, of course. Those are actually rocks and bits of sand and things like that.
Oh, they're not stars, they're actually stars.
No, they're not. They're called shooting stars, but they're not stars. What they are is pieces of space, of debris out in space. Space is full of dust and rocks of various sizes. And when those fall through the Earth's atmosphere, there's of course friction with the Earth's atmosphere because they're falling very quickly, and so they heat up just like, you know, when a jetliner goes through the atmosphere, the front of the jetliner is very, very hot, hundreds of degrees on the front. And that's because of the drag of the air rubbing against it, the friction. And the friction is enough to actually heat the rocks to the point where they actually glow. And that glow is what you see. You're seeing usually pebble-sized or smaller grain of sand-sized bits of stuff being pulled into the Earth's atmosphere by our gravity. And as it goes through the Earth's atmosphere, it gets heated up and it starts glowing, and then the smaller ones vaporize or break apart.
So when a debris falls on the earth, does it cause any damage?
The big ones can. The big ones definitely can cause damage. There are, you've seen all the craters on the moon. Those craters on the moon, which are visible even from 250, those are miles in diameter, some of them. And those are caused by pieces of space junk that hit the moon. Now, the ones that hit the Earth, there are some large ones. There's a meteor crater in Arizona, which is a mile or two across. And that was some very, very big thing indeed that hit the ground. The ones that we find, the rocks that actually land on here that came from space like that are called meteorites. And in fact, Bob Velliou, who is outside there, studies meteorites, and he has quite an extensive collection of them from all over the world.
Yeah, Bob is going to exhibit his collection here at the library this summer during July.
You should definitely see that.
Yeah.
It's a fascinating collection.
And he's going to do a presentation all about meteorites as well,
Yeah.
so hopefully you'll be able to come back for that too.
Yeah, now there was one just a couple of years ago now, a very large one that was about the size of a school bus that came down, and it exploded about 50 or 100 miles up in the Earth's atmosphere over Russia. and that made the news. You remember that one?
Yes, yes.
And that exploded with the force of several atomic bombs. And it was, the flash from it falling in was bright enough to be visible in full daylight. There are lots, one of the things out there in Russia is because they have so much auto insurance fraud, to get auto insurance you have to put a video camera on your car. So they caught a lot of good pictures of this meteor going through the sky. And an awful lot of people saw the flashes flash out of their window when the thing was in the sky, and they ran over to their window to see what it was. And then it exploded, and the shock wave shattered thousands of windows all over the place. And hundreds of people ended up with, lacerations and cuts because they were standing in front of the windows. Fortunately, it did not do that much damage. There was another one that fell in Siberia in the early 1900s, and it flattened trees. It fell in the middle of a forest and flattened trees for about 10 or 15 miles outside. And one of the theories as to why the dinosaurs died off is that a very, very large meteorite fell in right near the Yucatan Peninsula in southern North America, and the fireball and chaos, and it kicked an enormous amount of dust into the atmosphere, which caused wintry conditions for decades, disturbed things decades afterwards. Probably killed most of the life in North America and South America outright. And that's one of the theories as to why the dinosaurs all died off. So when you look at meteors, what you're seeing is this stuff falling in from the sky, and they come in various brightnesses and durations. Okay? Yes? You have a question over here?
I was just gonna ask about that, yeah. The extinction. So
Yeah,
you answered.
they have, that's one of the theories on extinction.